When we first got our 55 Thunderbird, it had been to a couple previous shops that had done some less than stellar work. One of the first things that we noticed was the poor installation of a steering rack. The car had a universal Flaming River rack, and somebody had made pretty much a homemade bracket. But the problem was the tie rod lengths were just all wrong for the car, which would have caused some terrible bump steer. Fortunately, Flaming River has just started making an actual rack and pinion kit for this car. And the rack comes with a special bracket that is designed to make the steering tie rods the same length as the original tie rods and put them towards the center of the car so that they're in line with the lower control arms, which are extremely wide on a 55 Thunderbird. And by installing this rack, it will greatly improve the handling of this car, especially at highway speeds when you hit a good bump. Once we got the Flaming River rack and pinion steering kit, the first thing we did was cut the old brackets off of the frame, and then we fit Flaming River's supplied crossmember to the car. The Flaming River kit's actually meant to bolt into the car. Unfortunately, some of the previous shops had welded all the holes shut in the frame, so we had to find the proper location that the rack was supposed to be mounted in and clamp it in place. Once we had determined the proper location for the Flaming River crossmember, we mounted the rack and tested all our tie rods, and then it was time to determine how to get from the steering column that Flaming River supplies to the rack. Since the Flaming River kit is actually designed for a stock Thunderbird, there were some unique challenges in getting the shafts to go around the Coyote's very large motor mounts and made up with the rack. Once I was satisfied that I had the mock-up brackets in the correct locations, I made a permanent upper idler bearing mount bracket and installed the steering column. Unfortunately, in order to get all of the linkage to fit correctly, I had to move the column up and over about an inch from where Ford had originally placed it. This required me to make a couple custom filler plates for the hole in the firewall that was originally intended for the steering gear to pass through during assembly. Once the column had been fitted and the upper idler bearing bracket properly assembled, we fit the motor and fabricated the motor mounts. Once the motor mounts were fabricated, we were able to finally fabricate the lower idler bearing bracket and fixture it in its permanent location. Putting the Ford Mustang Coyote motor in our 55 Thunderbird posed a bunch of challenges, mainly because the Coyote motor, being double overhead cam, is very wide at the top. The biggest challenge in fitting the Coyote motor to our 55 Thunderbird was the placement of the master cylinder. The original master cylinder was in line with the brake pedal, but the problem now is that there's a head and a valve cover where the master cylinder used to be. The best solution we could come up with was to move the master cylinder and Hydro Boost unit over to the side. But we wanted to keep the pedals in the correct position in the car so it would be functional and still be fun to drive. So what we ended up doing was designing a system that used a shaft to move the pedal motion over to the left about 6 inches. Once we had fabricated the reinforcing plate for the firewall, we mocked it up by welding some brackets to our welding bench. This allowed me to build the entire system outside of the car and not have to work under the dash and try to make some precision bearings and surfaces so this all worked smoothly. The other unique challenge here was what to do with our clutch pedal. Since we're running a Richmond 6-speed, which requires a hydraulic throwout bearing, we had to have a clutch master cylinder. In order to make everything work, we found our best option was to put the master cylinder under the dash. So the first thing I did, once I had everything mocked up on the bench, was to figure out my pedal travel and a proper bracket for the clutch master cylinder, which I then tack welded to the steering column and pedal bracket. After I had the bracket made for the clutch master cylinder, I set to make the brackets and the mounting points for the Hydro Boost and master cylinder. The first thing I did was make the two brackets, which I wanted to be fairly identical, to mount the shaft between the original steering column shaft and brake pedal shaft, and the new brackets to hold the master cylinder and Hydro Boost unit. During this process, I used a 5/8 wooden dowel to mock up in place of the shaft because I didn't want to cut our expensive 4130 chrome moly tubing and shaft until I knew exactly how long everything had to be. Once I had made my two brackets for the Hydro Boost and master cylinder mount, I tack welded them together and I clamped them to the firewall plate. Once they were clamped and in the place that I wanted them to be, I drilled the holes that would hold the studs for the Hydro Boost and the brackets all together. Once I had the brackets tacked and mounted, I carefully drilled the holes for the bearing carriers that would carry the shaft to transfer the pedal motion to the Hydro Boost. After I had the brackets and bearing surfaces mounted, I boxed the brackets to give them extra rigidity during heavy pedal usage. After I had the entire system mocked up on the bench, I cut it off of the bench and I proceeded to put it in the car and make any final adjustments that were required for it to actually work while it was bolted to the car. Once I was satisfied that the entire system was safe and would operate correctly at all times, I removed everything from the car and final welded all of the brackets. After we reinstalled the brake pedal brackets and shafts into the car, I was able to fabricate the stainless steel brake lines and bleed the brakes. Once the brakes had been bled and the steering shafts had been reinstalled, the car was once again able to steer and stop correctly.